Welcome to section 5.3, solving multi-step inequalities. Today's objective is to solve multi-step inequalities. So today we'll be doing both adding, subtracting, multiplying, dividing, and we'll be doing more than one step. And we solve these inequalities just like we would with equations. We use opposite operations. So we are going to solve these and we're going to check our solutions. So here we go. We have negative 6a minus 7 is less than or equal to 17. We're going to add 7 to both sides. And we get negative 6a is less than or equal to 24. We then need to divide by the coefficient of negative 6 to get a by itself. And a is greater than or equal to negative 4. Remember, we divided by a negative number, so we had to flip the inequality. Our answer is a is greater than or equal to negative 4. And then a reminder that in your book, you'll see it in set notation, a such that a is greater than or equal to negative 4. What we have to do again is we have to check our solution. So we're going to check the endpoint. And so I'm going to plug it in on my endpoint and make sure the numbers on both sides of my inequality equal each other. This tells me my endpoint is in the right spot. We get 24 minus 7 is 17, and we get 17 is 17. This again is my endpoint. We want to make sure that the endpoint is in the right spot. Then we want to look at a number that's greater than or equal to negative 4 to make sure the inequality is pointing in the right direction. And since we're looking for a number greater than negative 4, I am going to plug in 0, because 0 is greater than negative 4. Negative 6 times 0 minus 7 is less than or equal to 17. And is negative 7 less than or equal to 17? It is. So we have a good check. The solution is a is greater than or equal to negative 4. The next one, we have negative 4 is less than 5 minus 3n. We need to get the n by itself. I am going to do the inverse operation so I can move my 5 over first. So we have to subtract it since it's a positive 5. We have negative 9 is less than negative 3n. We need to divide by negative 3 to get n by itself, and n needs to have a positive in front of it, a positive coefficient. When we divide by that negative number, again, we need to flip the inequality. Negative 9, negative 3, we divide each 3, we flip the inequality, and it's greater than n. In your book, again, you're going to see this set notation where it's going to be n such that n is less than 3. We need to check this again, so we are going to check the endpoint. The endpoint is 3, so negative 4 is equal to, or doing our endpoint, we just want to make sure the numbers on both sides are equal to each other. And we get negative 4 equals 5 minus 9. And negative 4 equals negative 4 is true. We need to check a point where n is less than 3. And I am going to check 0, because 0 is nice and easy. For this point, we do need to use the inequality that we started with. So negative 4 is less than 5 minus 3 times 0, and negative 4 is less than 5. So we have verified our inequality is pointing in the right direction when we solved. So here we have, you want to fence on a rose bed that is adjacent to a deck. The length of your deck is 14 feet, and you have at most 44 feet of fence. What are the possible widths of the rose bed? For these type problems, I always recommend you draw a picture. So we know we have a deck that's 14 feet wide, and we know that we are going to build a rose bed off the deck. So we know that our rose bed, because it's adjacent to the deck, is going to be 14 feet wide. We want to know what these dimensions could possibly be. So what could be those widths, that x? So what we do with this is we know that the x plus the 14 plus x has to be less than our 44 feet. So x plus x is 2x. plus 14 has to be less than or equal to 44. That is my setup because my dimensions in red have to be less than or equal to 44 feet of fence. And then we solve. We're going to subtract 14 from both sides. Then we'll have 2x is less than or equal to 30. And we'll divide by 2. And we'll get that x is less than or equal to 15. So our dimensions can be anywhere from 0 to 15 feet. And make sure when you do word problems, you label it. So x has to be less than or equal to 15 feet. And it actually has to be between 0, anywhere between 0 and 15 feet is the width of the rose bed. So here it says, what are the solutions for the following inequalities? We are just going to solve them, and this is a multi-step. What I recommend is that we are going to distribute the 2 into the x minus 1 first to get 2x minus 2 plus 3x is less than 2. We have common like terms on the left side, and then we have this negative 2 here. So I'm going to do 2 steps at once. I'm going to add 2 to both sides. And when I'm adding 2 to both sides, I'm going to combine my like terms. So we have 2x and 3x, which is 5x. And this has to be less than 2 plus 2, which is 4. We divide by 5, do that inverse operation, and we add x is less than 4/5. That is my solution. So multi-step, a lot of these, if you have something outside of parentheses, generally you're going to want to distribute it in first. I suggest that you do that. Make sure you distribute fully. And then we get our x's combined and move our constants to the right side. So in this one we have 4n plus 2 is greater than or equal to 7n minus 3. I'm going to move my n's to the left and my constants to the right. To do that, I need to subtract 7n from both sides. I need to subtract 2 from both sides. And 4n minus 7n is negative 3n. Negative 13 minus 2 is negative 15. And then I'm going to divide by negative 3 to get n by itself. Again, using an opposite operation, we have multiplication, so I'm going to divide. And now we have n. We divided by a negative number, so we have to flip it, and this is less than or equal to 5. Here we have write an inequality from the word phrase, and then solve. 3 minus 11 times the number is more than 21 minus 5 times the number. I'm going to get x as my number, and the 3 minus 11 times the number. So 3 minus 11 times the number is more than, that means it's greater than, 21 minus 5 times the number. So now we have 3 minus 11x is greater than 21 minus 5x. I am going to get my x's to the left. I am going to get my constants on the right. And then we get negative 6x is greater than 18. Divide by negative 6. And again, we're dividing by a negative number, so our inequality has to switch or flip. And we get x is less than negative 3. Next one we have is 2 more than half of a number. So half of a number, again, I'm going to use x is my number. So 2 more than half a number. Half a number is 1/2 x, and we want 2 more than that, so plus 2 is greater than 27. All right, to solve this, we are going to get the x by itself. We're first going to move the 2 over. So we get 1/2 x is greater than 25. And we have a fraction, so we want to multiply by its denominator, or multiply by its reciprocal, so we multiply both sides by 2. 2 times 1/2 makes this go away, become just x. And then 2 times 25 is 50. And we have x has to be greater than 50 for this to work. So again, that's writing a inequality from word phrase. Very similar to what you guys did when we wrote for equations, except for now we're using inequality signs. So solve each inequality. 14 minus 6n is less than or equal to 2, 7 minus 3n. What we're going to do with this is we're going to solve them just like we have been before. And you're going to see some stuff that happens sometimes with inequalities that you'll also see on your homework. So first thing I want to do is I want to distribute my 2 into my parentheses. I get 14 minus 6n is less than 14 minus 6n. And when you solve this, you subtract 14 from both sides. We add 6n to both sides. And you're going to get that 0 is less than or equal to 0. And this is a true statement. There's no variable around. So what this means is that we can put in anything. This actually has all real numbers work. We can put in anything for n and we will get a solution. So this is all real numbers. Next one we have is 4p plus 3 is greater than 9p plus 6 minus 5p. We are going to combine our like terms on the right. We have 9p minus 5p, and we get 4p. We're going to get the p's on one side, and I'll get the constants on the other. And we get 0 is greater than 3. Here we have no variable, and we have 0 greater than 3, which is not a true statement. Since this is not a true statement, there is no solution. And in your book, what you will see is something called an empty set sign. You'll see this, that there's no solution. That means it's an empty set. There's nothing that works. You could also get a true statement if 3 was greater. Let's say this became 3 greater than 0 instead. That would also be an all real numbers thing because we don't have a variable and it's a true statement. This one is a false statement, so there is no solution. This is similar to what we talked about when we did identities. But we don't call inequalities identities. They're just either all real numbers or you're going to get a false statement where it's no solution. All right, that is it for section 5.3. Thank you for watching and have a nice day.